Hello everyone, I am Prasad from Structural Guide. Today we are going to discuss about concreting in hot weather. What is hot weather? What is high temperature? What happens if you concreted in hot weather? What are the most important things we need to consider when we are doing concreting at hot weather? All those will be discussed in this video. So I would like to request you all to wait till the end of this video. Then you will know many information. Okay, let's start. Hot weather. At the daytime the environment temperature or the ambient temperature is high. So when we doing the concreting at the daytime, it will directly affect to the concrete. How it happens? At the daytime, when the ambient temperature rises, the ingredients used for the concreting will be rise up. One such example is the aggregate. When they are exposed to sunlight, direct sunlight, the aggregate temperature will rise. Then if you are using the same aggregate for the mixing of concrete, the initial temperature of the concrete will be high. If you are going to do a very large concreting work, this place in temperature is very important. So place in temperature become higher due to the aggregate temperature is high. This is one example that we can know how the temperature at placing is high. So placing temperature is very important because beyond that, during the hydration process, concrete temperature increases. The hydration also increases the temperature due to the heat generated in the hydration process. So it will be increased. It will continue increasing. But there is certain limits, like now in a very thick concrete we limit the maximum peak temperature to 70 Celsius. That is because to avoid the formation of delayed retringites. Therefore we have to limit that peak temperature. For that we can't, of course there are methods that we can control the temperature or the heat generated in the hydration process. That is a one kind of a measure. Other than that, we can reduce the placing temperature. If you reduce the placing temperature, then the rise of the temperature from that level will be reduced. Therefore, it is important to reduce the placing temperature when very thick concretes are done. Right. Now let's move on to the what happen if you do the concreting in daytime. So at the daytime the temperature is high, then the evaporation is high. With that the concrete gets dried very fast. If you are doing a slab concreting work, when you pour the concreting at the daytime, due to the high temperature the evaporation is high, then it will dry fast. With that concrete will get cracked. Cracks like drying sinkage or sinkage cracks will appear due to the fast evaporation of the water. As we all know, the cover zone of the concrete will be a damage like cracking, or else higher evaporation rate will reduce the content of moisture in the concrete in the cover zone. So with that the strength development also will be less. So for example, if you have a grade 25 concrete, if the cover zone moisture is evaporated or the water evaporated, there won't be adequate moisture to react with the cement, then the grade of the concrete will become like 20, though we expected it become 25. So that is the range. So it will affect the durability of the concrete and lot of things happen thereafter. Therefore, it's very important to consider certain factors when you are doing the concreting in day. Right. Let's see one by one what are the measures that we can adapt for the thick concrete as well as a smaller concrete like forceps. So both I'm going to cover here. I'm not going to separate one by one. I'm not going to discuss separately one by one, but important facts that we can adapt during the concreting or during making the concreting to reduce the temperature rise and also to minimize the daytime concrete effect. Right. Let's see what are the best practices. One of most preferred method is the concreting at night. Whether it is a thick slab or whether it is a thin slab, if you can do it at night, the temperature rise will be less comparatively. Because now, if you do it daytime, the evaporation and all that will be high. But if you do it night, evaporation will be very less. The aggregate temperature is comparatively less, so that the rise of the temperature will be less. So for thick concrete, the peak temperature or the maximum temperature developed during the hydration process will be less. Similarly, for the slab also the same. That for thinner slabs it won't apply. Of course, there won't be much issues with the rise of the temperature, because thin slabs there won't be a very high. We can't expect very high temperature like 70 degrees, but the evaporation and all that will be less. Another important thing what we can do is adding the chilled water. Now, as I previously explained to you, the placing temperature is very important. So we can lower the placing temperature as much as possible by using cool water. Chilled water will reduce the temperature of the placing concrete. Okay, temperature, fresh temperature of the fresh concrete that you are going to place. Therefore, adding chilled water is one of measure we use to reduce the concrete temperature. Other one of important thing is cooling of aggregate. At the daytime, as we know, due to direct sunlight, the aggregate temperature will rise. So we can spray cool water, or at least a water that temperature below the ambient. We can spray into the aggregate, and then we can cool the aggregate. We have to be very careful about the moisture content of the aggregate. So during the mix design, this moisture content and all that you have to consider. More importantly, you can reduce the aggregate temperature so that you can get the low placing temperature. Right. Other important thing is we can use low heat cement. Now we know the hydration process generates the heat. During the hydration process, cement and water react and concrete is made. I mean, during this process, concrete is developed or concrete is made. So the cement is one of important parameter in this process. So if we can use low heat cement, that is kind of a cement that reduces less heat during the hydration process. So that also can be done. If you use such a cement, your heat will be less. There are products in the market, so you can buy those products. There are specifications for those, so you have to study in detail about this and you can use this. With the rapid hardening cement hydration process, at a shorter period of time, the heat will be high. With that, the temperature will go up. So we can reduce not using rapid hardening cements. Other important thing is the monitoring. We have to monitor the concrete temperature, not only the fresh concrete. We have to monitor the temperature of the poured concrete. If you have done a mock-up test, we might not need to monitor the concrete temperature that is poured into the structure, but placing temperature we have to monitor, because with that only we can have a certain indication on what sort of a temperature is there. If it is greater than that is specified our specification, or according to the design, there may be or according to the mock-up test, there may be a certain temperature that is finalized to place. So if, for example, say we are going to consider the placing temperature as 25 Celsius. So if you monitor that continuously, when the concrete truck came to the site and you can take a sample, you can get the temperature and see whether it's within the limit. So if it is within limit, you can proceed. Otherwise, there will be issue that we have to identify. So for that, we need to monitor the concrete temperature. And the last thing that I am going to discuss is the curing. Now we know that when you're doing the concreting at daytime, as I mentioned previously as well, the evaporation is very high. So water or the moisture in the concrete will be evaporate very fast. So we have to maintain this moisture content and in the concrete cover zone to make it happen the hydration process completely. So what we can do is once you place the concrete, then immediately after that, that is when the concrete get start hardening and when we can place some cover or we can spray a curing agent, at that level we can use this curing methods. So immediately after means once you pour the concrete, you can't do the curing because you can't. I mean, it's not at least gain the strength, and you can't put the water and all that. It's not hardened. When the concrete gets stiffness, you can cover it by a polythene. Smaller concrete, you can do a polythene and all that. Thick concrete, you have to follow the specification. Basically you are not allowed to put the water in thick concrete. You have to use a certain curing method that is finalized during the mock-up test. You have to finalize a curing method during the mock-up test. Then that particular test, that particular curing method, you have to apply for thick concrete. But for a thin concrete like floor slabs, you may put water and or you may put polythene to cover it. Then evaporation will be less. Otherwise, you can make a curve around the floor slab edge and then you can fill it with the water. These kind of a methods you can use to control the rise of the temperature and the evaporation of the water, and this by that you can control the cracking of the concrete. Right. With that, I'm going to conclude today's discussions. We discuss about the concreting of hot weather. Also, we discuss about the thick concreting during the hot weather, and also what sort of things we have to consider when you're handling the thick concretes. Right. I think we were able to share some of most important facts about the concreting. Thank you very much for watching our videos. We will meet again for new video. Thank you very much.